Hey everyone, welcome to the first proper lecture in this series on quantum computing. Today we're going to be looking at sets. So the first question we've got is, what is a set? And then the second one is, why bother looking at sets? So the first question is pretty easy to answer. Sets are just collections of things. So to give you some examples, A, B, C is a set. Cat, dog is a set. 1, 2, 3, 4 is a set. We write sets in these curly brackets here. Now, why do we do this? Well, this is a building block of pretty much all modern maths. So we're going to need them to do linear algebra. And linear algebra is the language of quantum mechanics. So we need to use them for linear algebra, and linear algebra is the language of quantum mechanics. So let's start by talking about some basic properties of sets. So the first question we can ask is, when are two sets the same? Well, it's when they contain exactly the same objects, regardless of the order we write them down in. So this means that C, A, B is the same as A, B, C. It doesn't matter if we're written down in a different order, same objects are in them, it's all okay. But an example of things that aren't the same, AB is not the same as ABC, because I have C on the right hand side, but not on the left hand side. And the other thing we should know is sets don't have duplicate items. I can't put something in a set twice, so I can't have ABB as a set. So now we've talked about sets, we can talk about combining sets. And there are two main ways we can do this. We can do unions. Unions take one set, AB, and another set, in this case CD, and give us back a new set that has everything that's in either one of them. So we get A, B, C, D. So we're just kind of shoving them together. If something's in both of them, so we'll note that B is in both sides. It only appears once in the union. So here we just get A, B, C, D. We don't get B twice. That's because sets can't have duplicate items. The other way we can combine sets is the intersection. So the intersection is what is in both sets. So if I have the set ABC and I intersect it, which is what this symbol means, with B, C, D, I just get back B and C, because B and C are the two elements that are in both sets. So now we've talked about kind of the two ways we combine sets, we can talk about subsets. So subsets is when one set is contained within another. For example, 1, 2, 3 is a subset of 1, 2, 3, 4, because everything on the left hand side is on the right hand side, so we use this symbol to represent it. If something is not a subset, like 1, 2, 5, and 1, 2, 3, 4 again, this is not a subset, so we put a line through it, because 5 is on the left hand side, but it's not on the right hand side. next we can talk about sizes of sets. So the size of a set is called its cardinality. And this is a fancy term which just means how many items are in it. So we use this symbol, the pipes, to say the cardinality, and the cardinality of this set, ABC, is just 3. Cardinality of DE is 2. Now I will mention that you go on to do more set theory and you look at kind of infinite sets. This gets a bit more complicated, but for our purposes, this is more than good enough. So finally, I'm going to talk about some useful sets to know. So first set to be familiar with is the empty set. This is the set with no objects in it. So there's nothing in it. And we often write it using this fancy symbol, which is a circle with a line through it. The next set you should be know is the natural numbers. So natural numbers are just the counting numbers. So we start at 1, we have 2, we have 3, and so on and so forth, and it just goes on forever. Note, we don't have 0 in it. Some people do put 0 in it, I'm not going to. And we often write it with this fancy looking N here. Then we have the integers. And this is all the negative numbers. So -3, -2, -1, and it goes on forever this way. Then we have 0, then we have 1, we have 2, we have 3, and it goes on forever this way as well. And this has this symbol, the fancy Z. And finally, we have the real numbers. The real numbers are kind of all the numbers we usually think of. So it's 1.1, it's 2.7, it's just all the numbers we usually think of, including weird numbers like pi, e, all of those live in R, and we write it with this fancy R here. And finally, the last topic we need to talk about is membership. So we can say the number 1 is in the set 1, 2, 3, and we represent that with this symbol here. So this is 1 belongs to 1, 2, 3, but 4 does not belong to, so we do the symbol, but with a line through it, 1, 2, 3. And we say 1 is a member of 1, 2, 3, but 4 is not. So that is everything you need to know about set theory for the rest of this course. I hope to see you in the next one.